Hi all, this is lecture 8 of marketing research, and today we start doing the testing the data. Quantitative analysis techniques is about to begin. So we are starting with chapter 14 of the textbook, focusing on testing for difference. So in terms of what we're going to cover in this lecture is the testing for difference, which will focus on Z-tests versus T-tests, the different types of T-tests, and then we'll also look at ANOVAs and what's also called MANOVA or sometimes N-way ANOVA. So this learning outcomes that relate to this week are the establishing methodological quality, reliability and validity of the data collected. We'll look at confidence intervals and reliability, and mostly we'll focus on integrating all types of relevant evidence towards finding solutions to the marketing problem. So the reason we need to test for difference. So when we run descriptive statistics, we can find out that there are differences between groups, the percentages and the means that exist within a group. A bit more, besides the descriptives, we can do a compare means where there's the procedure there that will then give us an output that looks like this down the bottom. And as we see here, we've got testing for satisfaction levels between females and males. So the mean for females in terms of satisfaction level is 5.07, whereas the satisfaction level mean for males is 4.35. So we could report that females have a higher satisfaction level than males, but what we can't report is whether this difference is statistically significant, i.e., does it actually matter? Is it a significant difference, and does it matter that the means for the females versus the means for the males is slightly higher? So that is what we're looking at in terms of the test that I'm going to show you. So before we get started on the different tests, we need to look at the hypotheses that we use in order to test for. So there's two basic hypotheses. There's the null hypothesis, and then there's the hypothesis, or also known as the alternate hypothesis. So this week we're focusing on the hypotheses that relate to difference. When we get into next week and the week after, we'll be looking at the second types of hypotheses that relate to relationships. But this week we're looking at the null hypothesis that states that there is no statistical difference between variables. And the alternate hypothesis to this is that there is a statistical difference between variables. In reporting our statistical significance, we need to be aware of two types of errors, error alpha versus error beta, or type 1 and type 2 error. Type 1 error is when we reject the null hypothesis and accept the alternate hypothesis when in fact it is not actually true, as in we accept that there is a difference in the relationships when in fact there isn't a significant difference in the relationships, or there isn't a significant difference, or there is no significant relationship. Type 2 error is the opposite, when we accept the null hypothesis and reject the alternate hypothesis in error. That is that we say that there is no significant difference or significant relationship between variables, when in actual fact there is a relationship or difference there. In terms of addressing these types of errors, the only thing that is proven to solve all of these problems is to increase the sample size. However, as you have discovered in doing your own projects, it's not as simple as it sounds just to merely get more respondents in order to solve your error problems. The other thing to be aware of is, what do we mean by statistical significance? At what point is something considered to be significantly different or have a significant relationship? Here we look at the reliability measure, often called the p-value. The standard one we use is 95% reliability, or a 95% confidence interval. And this is often reported in the statistics as 0.05. So this is the baseline in which we would accept the alternate hypothesis. However, if we want to have an increased reliability, as in I have decreased our type 1 and type 2 errors, we can say that we'll only accept the alternate hypotheses when the significance is below 0.01 or has 99% reliability. However, if sometimes we can't be that sure, and the statistics emerge at less than 0.1, as in it is at 90% reliability, and we often will accept the alternative hypothesis in this case, particularly in survey type research. However, it is reported as being slightly less reliable in terms of our confidence in accepting that hypothesis. So the next thing we need to do in terms of doing the analysis is make sure that you know your data, because what can be measured and how it is measured is dependent on the way it was measured. So when we get to the quantitative data analysis, we'll talk about metric versus non-metric variables. So as you can see here, our non-metric variables include the binary, nominal, ordinal types of measurements, and the metric variables include discrete and continuous. So just to recap the measurement, so binary is things like males and females, yes and no. Nominal is the groups in which that there is no relationship between the groups. In this case, the nominal metric here is hair color. And the final non-metric measurement type is the ordinal. For example, if you were to have a measurement in a rank order of most preferred to least preferred. On the metric side, we have two different types: discrete scale, which we often use in terms of a Likert scale. In this case, a discrete scale is that you can only select 1, 2, 3, 4, or 5. So there's no 4.5, there's no 0, there's nothing like that. Whereas on a continuous scale, we can start at 0, but we can say any point along this line, which might be 3.75, can be measured. Often in a continuous scale, other types of continuous scales are a weighting scale. So the other thing to be aware of is to know your tests. And the test that you can run depends on whether you have metric versus non-metric data, and the types of, and the number of samples or the number of groups in which you want to test. So for example, we're going to focus on this side of the line in this lecture, or in the videos I will create. So on the metric, when we have metric data, if you have one sample, we can run a t-test or a z-test. If you have two or more samples, for example, if you want to compare differences between males versus females, or high, medium, and low users, we go to this side of the data, and if the samples are related, we can do a paired t-test. What we mean by related is, for example, if you are running an experiment and you have measured people's responses before the manipulation and measured their responses after the manipulation, it means those before and after samples are related. On the other side, if they're independent, for example, males and females are independent groups, they don't necessarily function in relationship to each other, We can run an independent sample t-test, a z-test, or an ANOVA. We run an ANOVA. The difference between the independent sample t-test and the ANOVA is that independent sample t-tests are for when you have two groups, e.g. male-female, and an ANOVA is run when you have more than two groups, for example, high, medium, low users. So this ends this particular recording. In the next recording, I'm going to talk about z-tests versus t-tests and show you how to run the t-tests and how to analyze the output data in SPSS and PSPP.